Oh, we're here. All right. So I'm going to just wrap this up. I was going to do the Hummer and the Toyota problem, drag problem, because it really shows that it's a pretty darn good estimate of even if you're driving a Toyota, the difference in energy that you're burning between 60 miles an hour and 70 miles an hour, right, and 80 miles an hour, say. It's not as small as you might think. Oh, I'm only going 20 miles an hour faster. The kinetic energy that you're adding to the system is huge, and the drag that you're increasing is squared. Those velocities are squared because remember, our equations for drag, C, our force of drag, is equal to 1/2, and each thing has its own like little drag coefficient. 1/2 C times rho, which is the air resistance, or the density of air, times and when if we get into baseballs and stuff like that with their seams and you start throwing them, then we got to include the spin of the ball and stuff. It gets really crazy. But anyway, 1/2 C P times the area times the velocity squared. So with the 90 kilogram, and we said that so in other words, you're just going to calculate when mg is equal to 1/2 c rho a v squared, and you're going to find a v1 for the 90 kilogram diver skydiver, and v2 for the 60 kilogram scuba skin diver, parachutist. They're both parachute. So you're going to find those guys. Okay, find those, and we're going to assume that the distance is 60,000 feet, is 6,000 meters. The distance 6,000 meters for both of them. This is a constant velocity. Then it becomes pretty easy. D is equal to V times T, and so it becomes a pretty easy calculation. Okay. All right. Now the next one is about Hummers. The difference between, and we'll just look at it real quick. The difference between Hummers and, here's a Hummer, H2 SUV, 0.64 is its coefficient of drag, and a Toyota Camry, 0.28. Notice, that's almost 3 times. Or it's about 2.7 times greater, the coefficient of drag. So for problem 10, I love that joke about Hummers. You're probably going to hear this. For those of you who watch this video, you've already heard it. You know, there's the old joke. What's the difference between a porcupine and a Hummer? A porcupine has all its pricks on the outside. Anyway, all right. So, sorry. I apologize to anybody who has a Hummer. Sometimes you need one. I mean, there are people that are out in the woods of Oregon and stuff like that that are loggers. They need actually the original big Hummer to get over the logs and drive through logging trails and stuff. So I get that. I don't think they're needed in Johnson County. All right. So anyway, so let's take a look. So we've got a Toyota Camry, and I think they're talking at 70 kilometers per hour and 90 kilometers per hour. We got to, and all they wanted you to do is compare, is look at the coefficient. You got to do 4 calculations of the coefficient of drag for problem 10. Okay, and so let's take a look at it. So I'm writing stuff down and not showing anything. So the Toyota Camry, the C is equal to 0.28. Hummer, C, the Hummer is equal to 0.64. Okay. Did they give us any other information? Okay, I'm going to look at the problem real fast because I'm looking at the solution part so I can see what. Drag here is 2.44, 0.7. Okay. So did you get that? The area for the Toyota is 0.7 meters squared. Area for this one is 2.44 meters squared. So you can see that the drag force for the Hummer, I mean, just by knowing that the force of the drag is equal to 1/2 C rho A V squared. When they're going the same speed, massive area. Almost three times the air, almost 3 times the area. 3 times the coefficient of drag. 3 times, that's 9 times larger, the coefficient of drag. I mean, that's huge. It's not going to come out to be 9 times bigger, but I mean, it's just amazing. And that's why energy costs for those are so much higher. All right, that was good.